In this case, we are going to consider the last section of our trigonometric graphs, working with the graph of a tangent, the tangent graph that is y is equal to the tan of x. So we are going to consider the basics of our graph and also the effects, just like what we had before on the graph of a sine and that of a cos. The same effects as before, where we can have a tan of x plus p. Then we can have the effect of what? Of the q, which is our vertical shift. So originally, if we are to consider the graph of a tan, one, it is actually different from what we had from these two graphs. Remember, we had a spacing of 90 degrees before, but this cannot happen on a graph of a tan. The spacing is going to change. If we are to consider the tan of 90 degrees, we do not have a value there. That's an infinity. So we cannot have a spacing of 90 degrees because there will be no value at that 90 degrees. So the spacing this time will be at 45 degrees. So using a spacing of 45 degrees, I want us to consider the graph of a tan. So for us to understand this properly, let us just have y is equal to the tan of x. Using an interval, all right, let us just take from minus 180, all right, minus 180 degrees up to 360. All right, let us just take up to 360 so that you can try to understand much better about the values of x. With the spacing of 45 degrees, with the spacing of 45 degrees, this is what we are going to have. All right, so that's all right, let's hope it's not going to affect here. So this is our x and the y values. So from minus 180, we are going to have minus 180 plus 45. That will be what? Minus 135. If we add 45, that is going to be minus 90. If we add 45, that is going to be minus 45. If we add 45, that will be what? 0 degrees. If we add 45, that is going to be 45. We add 45, that's 90. We add 45 there, that's what? 135. All right, we are adding 45, that's going to be 180. All right, that's going to be a lot of values. Let's just hope we're going to be able to consider that part on our graph there. 180, 225. 270. We add 45, that's 315, 360 up to 360. All right. So each value can be determined. We can just use our calculator, then note our values where we have got exact values which can be used to sketch this graph. All right. So at 0 degrees, considering tan, that's tan 0 there, which is gonna give us what? That's a 0, all right? So, all right, so guys, sorry, minus, I need to start at minus 180. Minus 180. All right, that's a 0 there, all right? So this is gonna give us a 0. Minus 135, minus 135, 135, that's a 1. Minus 90, all right? Just put this and see what's going to happen. At minus 90, that's an infinity. We do not have a value there. So this is what? An infinity. So minus 45, you do the same. Minus 45, that was going to give us negative 1. At 0, you do the same. All right, let us just have this. That's 0 there. At 45, it was going to be 1. This was going to be infinity again. 135, negative 1, 180, a 0, 225, 1, 270 was going to be infinity, 315, negative 1, 360, 0, like that. All right. These are the values that we are going to need on our graph here for the x values. Right. So that is going to be 45. So guys, because of the space here, if I try to say that's, let's see, 45, 90, 135, 225, 270, 315, 360. Oh, let's just try to do that so that we can just try to space a little bit. All right, so I'm just going to use two boxes to represent 45. So that's 90. All right, 135 according to the spacing that we had on our x values there. So that's 180, 225, all right, 270, 350. Oh, guys, it's exceeding. Is that so? 45, 90, 135, 180, 225. All right, no problem. No problem. 315. So 360 was going to be somewhere here. Let's just put it somewhere there. Okay. Then the negative up to negative 180. That's negative 45, negative 90, negative 135, and negative 180. So that's what you're going to have, and the corresponding y values 1, 2, and so on and so on. Negative 1, negative 2, and so on and so on. So you're going to mark these values, guys. So the infinity part, where we do not have values at minus 90, at 90 degrees, at 270 degrees, those will be our asymptotes. The graph cannot pass through those values, meaning to say we are going to first indicate those asymptotes before having our graph, to say our graph cannot pass through minus 90 degrees. At minus 90 degrees, it is an asymptote, that one. At what? At minus 90 degrees. That's an asymptote. At 90 degrees, an asymptote again, the graph cannot pass here. The points cannot pass that. Then the same at what? 270. We are limited to those points. All right, so let's mark our points. Minus 180 versus 0, that's here. Minus 135 versus 1, that's a positive one. Minus 135 versus positive 1. Then we have got infinity. There's nothing there. Minus 45 versus what? Minus 1. We have got 0 versus a 0 there. 45 versus what? Versus what? Infinite at 90. 135 versus minus 1. 180 versus what? Versus a 0 there. 225 versus 1. Infinity at what? At 270. At 315, that's versus -1. At 360 degrees, that's at what? At 0. So these were the points that you had formed. But we cannot join these points because of the asymptotes that we have. So we are limited in this case. So where we can properly see the sketch of the graph is here in between these two asymptotes, or in between these two, so that we can tell what is happening between these 2 points, all right? So if you consider what is happening here at between -90 and 90, we're going to have something like an S like that, all right? Limited to say it cannot reach this, it cannot reach this part. So we just save something like an S, trying to approach that, but it cannot reach the 90 degrees, all right? It goes to the 0 there at the origin. We have got this part. It tries to reach the 90, but it won't reach that. It will be approaching that. That is a proper sketch that we can use. From 0 to 90, this part here that we are given where there's an asymptote, that's a half of what we see on the other side. That's another half. So a complete cycle for the graph of a tan it has been completed. The graph has been completed. From -90 to 90, we have got a complete cycle, which is in within 180 degrees. We have got a complete cycle. So just like what we have here between the -180 and -135, this is the shape like 0, 45, like it was going to be like that. So we're going to have a shape like this. This is the half of the graph. This is the half of the graph. This one, it's half of our graph. Another half in these 90 degrees is taken. So we are saying it's a complete cycle that we have. Here we have got another half this side. That's a half of a cycle. If you take it to this one, it's a complete. So in within 90 and another 90, that's what? 180 degrees, a complete period. And also this part. Here we've got a complete cycle here. So this is what we are going to have. Limited at 90, at -90, at 90, and what? And 270. This is what we are going to have as y is equal to tan of what? X. So if your graph was to be taken from 0 to 360, it was going to be like this. From 0 to 360. This is what you're going to have. The issue of the period is to say when we have a complete cycle, it happens in within how many degrees? From 0 to 90, it's a half cycle. There's another half. So a half and a half, guys, in within 90 and another 90. So it's going to give us 180. So that is the period that we have originally for the graph of what? Of a tan. Originally, from the graph of a tan, our period is what? 180 degrees. It completes its cycle in 180 degrees. Remember the spacing, we use the spacing of what? 45 degrees. This is very, very important whenever you are to attempt your questions. All right, then the domain can be any x value that you're given, depending with what you're given on the question. That's your domain from minus this to this. Then also that is going to affect the range. Our range will be taken from minus infinite up to infinite. The y values these, remember, there were infinite values when we were using that. Those are asymptotes. So what is important? Shape of the graph. To understand the interval that you're given. And on the domain, x cannot be the values of what? They are asymptotes. At 90 degrees, x cannot be equal to 90 degrees. At 270, x cannot be equal to 270. At minus 90, x cannot be equal to that. So meaning to say, when you are to write down your domain, you must include that x cannot be equal to those given values. Yes, x is any value that you think of, any real value. But it cannot be what? What we have on the asymptotes. All right? It cannot be 270 degrees. It cannot be negative 90 degrees. That's another thing you must consider whenever you are to refer the part of your domain to say it can be any real value, but x cannot be what you're given on the asymptotes depending with the interval. So if they say it from 0 to 360, we are only limited with the 90 and what? 270. But according to this interval from minus 180 to 360, minus 90 is also part of your asymptote. So x cannot be equal to minus 90 degrees. All right. So that is what you can have. And the other thing, the x-intercepts, as we can see them, guys, direct on the graph as it is. And another part, the most important points that we are very, very notable, 45 versus 1, minus 45 versus minus 1. Those are very, very notable points. For any effect, use those points as an advantage because they are notable points that we can shift. We can shift those points according to any transformation or effect that we have according to what we had before. So I'm not going to dwell much on this graph because we had already the basics, guys, in order for us to understand more. It'll be on the questions, all right? Just basic questions that we are going to have later on. All right, let's consider to say our graph, just like the previous graphs that we had, we can have the effect where we have got y is equal to maybe 3 tan of x, the effect of a, 2 tan of x, 3 tan of x, where the is a, the number, affecting the whole graph of a tan. This multiplies the output. If there is no other effect, we just take, this is the graph of a tan as it was. So this time when it is y is equal to 2 tan x, we just say it was originally what? Tan x. The graph of tan x is just multiplied by 2. So what does it mean? The output values, you multiply them by 2. If it was at 1, you multiply it by 2. So for us to have the graph of y is equal to 2 tan x, 1 is now at what? At 2. So it's now minus 135 at 2. Minus 1, if you multiply by 2, it will be at negative 2. 1 at 45, multiply by 2, it will be what? At 2. So that is the condition. This one at negative 2, this one at positive 2, this one at negative 2. Remember, guys, if you multiply 0 by any number, it remains as a 0. So these ones that are at 0, they will remain at 0. So meaning to say our graph is now like this. At this point, minus 135 versus 2, you join it back to what? To 0. In this case, it will be something like this. At this point 2 to the origin at 0 there, then to the what? To minus 45 versus minus 2. it has affected the y values of the graph. Y is equal to a f of x. F of x, y value. Just multiply the y values by what? By a, direct. Same concept here. We're going to have something like this to this value, like this, all right? Then here, this way, up to 0 there. So this is now the graph of y is equal to 2 tan of what? 2 tan of x. From the original graph of what? Y is equal to tan x. That is the effect. In the same sense, just like before, the effects can also be a horizontal, it can be a vertical shift. This graph also can have the same effect. Considering the vertical shift, the effect of Q, which can be going up or down. Y is equal to the tan of x plus 1. What does it mean? We are shifting our graph 1 unit up. If it is minus 1, 1 unit going down vertically. So what does it actually mean? If we have got y is equal to tan x plus 1, the points will be shifted up. 0 is going to go up 1 unit. So we're going to have 0 now at what? At 1. What was at 1 is going up 1 unit. So we're going to find 1 is now at what? At 2. This is what we're going to have. The same concept, minus 1 goes up 1 unit. So find now at what? At 0. 0 goes 1 unit up. It's now at 1. 1 unit up. It's now at 2. So this is what you're going to have. It has shifted 1 unit up. So the same if it was 1 unit down, you take your points going down from the critical points. Same here, minus 1, 1 unit going up, it will end up at 0. 0 will end up at 1, 1 will end up at 2. So we're going to have this one, something like this. Minus 1 shifted up 1 unit, it's now at 0. 0 is now at 1. So we're going to have a shape like this. The graph has shifted. That's y is equal to the tan of x plus 1. 1 unit up. Every point is going up. Every point is going up. From the original graph that we had, every point will be going up. So we must be very, very careful in attempting these typical questions. So the effects of A, the effect of Q, taking our graph up or down, the A multiplying the graph of tan as it is, do not affect anything on our asymptotes. But if we consider, all right, there is a B here. If we consider the B and the P, this part of B and this P, these two, they are going to affect our graph. All right. These two, they are going to affect our graph in the amplitudes. In the asymptotes, I mean, the asymptotes will be affected. Previously, we just had Just a normal effect, just all right, the graph as it is, all right, this one is. But let's say we had something like this. We had, all right, let's start with the effect of what? Of B. Y is equal to tan bx, effect of B. As we had before, the period and spacing will be affected by what? By B. It affects our period and also the spacing. So let's take for an example, we had this graph of y is equal to tan half x, so that we properly see the effect of B. Y is equal to tan half x. From the graph of y is equal to tan of x, it means our spacing is going to change as the period is going to change, the new period from the old period. For the graph of what? Of a tan. Our old period is 180 degrees. We divide it by what? By B. The new spacing is going to be taken from the old spacing, 45, divided by what? By B. Just like what we had previously for cos and sine, but only that these ones, they were operating at 360 for the period. The spacing at what? 90 degrees. They are the same, cos and sine. The tan is on its own. It has got its own period, 180, its own spacing, 45. So for a new graph now, when there is an effect from this original graph, where there are now effects like this, where B is involved, that's where now we have to consider the new period and the new spacing. So in our case, the new period from the old period of 180, we divide by what? By B. Our B is what? Is a half. So meaning to say 180 divided by a half is what? That was going to give us 360 degrees. It completes its cycle in 360 degrees. And its spacing is going to change from the old spacing of 45 degrees. We divide by 1/2. That was going to give us 90 degrees. So guys, if we have a spacing of 90 degrees, 90, 180, 360, it means we are not going to have these asymptotes where they are. Our spacing is now 90 degrees. So meaning to say that, I want us to see what we are having there. At 90 degrees, I don't know if it's going to make sense if I'm going to use the same graph here. What was happening at 0 degrees here? It is now happening at 90 degrees. Our spacing 90, 180, 270, 360. That's our spacing. Meaning to say the same way as we are going that other side, our spacing will be 90 minus 180. So this is what I want you guys to understand. What is happening, or what was happening at 0? Originally, we can see that there was a point at 0 there, which is what? At 0. It is what we now have on the spacing that we have this time of what? 90 degrees. What was happening from that spacing? Right? So the first point is 0. The 0 is 0 there. The first point here, it's that's why I was supposed to just draw another one separate so that it does not confuse you guys. But anyways, let me just see. Let me change this one so that you can see. Let me do it like this. So the origin is our origin. This one is not gonna have an effect. But these are the points that we had originally, 45 degrees. So let me do it this way. So what was happening at 45 degrees as our first point? 45 was our first point. In our case, our first point is 90 degrees. So this 45 was versus 1. So it means that is exactly what we are going to have at what? At 90 degrees. It is going to be what? 90 degrees versus 1. All right? So we no longer have an asymptote for this graph. For at 90 degrees, for this one value of 90 degrees, because it's now at what? At 1. The asymptote was for the original graph of what? Tan of x. Okay? This is what I'm trying to say. What was happening on the first point, our first point, you take in that manner. First point, 45 hours, it's what? 90. At 0, there's nothing. Don't consider that one. That one is not affected. So if we move on to the second point of our original graph, the second point of our original graph was at what? 90 degrees. Remember, it was 45, 90, 135. Our second point was at 90 degrees, where there is what? An asymptote. This is the second point of our original graph. The second point on our new graph is at 180. Remember, the spacing is now at 180. So what was happening at 90 is the one that is happening at what? At 180 this time. Meaning to say our asymptote for the new graph that we are going to have is going to be at what? 180. Remember, at 90 it was an asymptote. So for this one, it will be having an asymptote at what? At 180 degrees. For the new graph, that is going to be our asymptote, this one. This is for the new graph. The original one was happening at 90. So the point 90 is the same as the point 180 for the new graph. That's your second point. So you do the same thing. Your third point from the original graph, it was 135, corresponding to what? To minus 1. But our third point as of the new graph is 27, 90, 18, 27. The third point is 27. So what was happening at 135 on the old graph is the same what is going to happen at 270 on the new graph. So it's 270 versus minus 1. So it was going to be at minus 1. We have a point there. That's our third point. The fourth point at 180 degrees. That was the fourth point from the original graph at 180. From the new graph, our fourth point is at what? At 360 degrees. What was happening at 180 on the old is the same. What is happening at what? At 360 degrees for our new graph. So it is the same even for this negative. It's the same even for the negative values. So if we are to take from 0 to 180, not considering the negative so that we do not have confusion there, it means we're going to have 180 as our asymptote. Our graph was going to be taken from 0 like this to this 90 versus 1 like this. And that is our asymptote at what? At 180. Then another half this side here. We need this part which is in green like that. Up to 360 degrees at what? At 0. So this is what is happening. In 360 degrees, it is a full cycle, a half here, and this other half. It has completed its cycle in 360 degrees, which is the period that we are given there. All right, so I just hope, guys, you understand. If you do not understand, then let me know so that we can try to have another class on this part of this graph of a tan, but that is what you have there. Even its asymptote is now affected. It is the same thing. This effect, guys, is not only, it is also on the horizontal shift. The horizontal shift also affects the asymptotes. I want us to see, or just look into the effect of this one, of the horizontal shift from the graph of a tan that we are given there. Remember, the horizontal shift is the P, the effect of that P. Y is equal to the tan of x plus 45 degrees, tan of x minus 45 degrees, whatever that you're given there. From the graph of y is equal to tan of x. It simply means we substituted x plus 45 there to get this x plus 45. We substituted that in place of x, which shows us that it's 45 degrees to the left. Remember, a plus means to the left. 45 to the left. Horizontally. So the points we're going to shift, what we have at 0 degrees is going to happen at 45 because we're going to the left. This is the effect. What was happening at minus 135? We are moving to the left. So even the asymptotes, they will be affected from where they are. We'll be having this asymptote now moving to the left 45 degrees. We'll now having our asymptote here. It's now at minus 135. The asymptote, which was at 90, it's going to move also from where it is, 45 to the left. So from 90 degrees, we'll end up having this at what? At 45. The one that was at 270, if it moves 45, we have this asymptote now at what? At 215 degrees. At 225, I mean, here. The asymptotes are also affected. They have moved. Each point is going to move. The minus 35 to the left, meaning to say it was at 1, we are going to have it at minus 180 versus 1. Minus 180 was going to move there to another point there. That is the point that we're going to have. It was going to be minus 180 at 0. That point is going to be at 0. 45 degrees to the what? To the left. So we're going to have a shape like this. This graph has moved from where it was originally. It has moved. The same with this part. If we had minus 45 versus minus 1, it is going to shift to the left. So it is going to be at minus 90 versus minus 1. 0 shifted to the left. It's now at minus 45. 45 is shifted to the left. It's now at what? At 0. So it's 0 versus 1 now. So our graph will be limited with the new asymptote that we now have at what? At 45 degrees. This is the graph. So everything has shifted 45 degrees to the left. So this is the idea. So we no longer have this originally the way that it was here because it is what? It has been shifted. Okay, let's just remove it. This is what happened. It was here at minus 45. Now it's at what? At minus 90 degrees versus minus 1. The same thing, this piece that we see is going to be shifted to the left 45 degrees. We just take it to the left like that. It's now like this. To the left. Taken to the left. 45 degrees. So if it was at 225, at what? At 180. 225 was versus 1. So it means our 180 is versus 1. If it was at 180, now it's at 135. If it was at 135 versus minus 1, now it's at 90 versus what? Minus 1, because we're going to the left to subtract 135 minus 45. So the points, they're affected. The same with this part. What is happening at 315 is going to happen at what? 270 to the left. What is happening at 360 to the left at what? At 315. So we are going to move this one to the left. There's going to be something like this. This is the idea. So meaning to say what was happened to the other point, 360 is now going to be at 1. So it's going to be something like this, at 360 at 1. So that's the effect. Y is equal to tan of x. It was to the left, so that was what? Plus 45 degrees. All right. Plus 45 degrees. From the graph of a tan that we had, every point moved. From the asymptotes, which was at 90, it moved to 45. It's now at 45. The one that was at 270, 45 to the left, it's now at 225. Each point, we are moving to the left, 45 degrees, 45 degrees. It is the x which is affected. The y value remains. If it was minus 135 versus 1, it would be minus 180 versus 1. If it was 45 versus 1, we just move to the left, so it will be 0 versus 1. The y value is not affected. It is the x value which is affected as we are moving to the left. Horizontally, those are x values. So this is it. Do revise. Know the basics from the original graph. If you understand the original graph, it will be easier for you guys to attempt or to answer any question where there is now an effect. But the major case that you're going to actually have, it'll be on this, the period and the spacing part, in case that you are to draw this. But like I said, we are going to also have a class where we are going to refer to the sketching of these graphs using a calculator, where you don't need to like, okay, what is happening? You just, okay, whatever that you're given, maybe they've given you all the effects at once, 2 sine of x minus 45 degrees, then there's a plus 3. Guys, there are so many transformations, so many effects. So for you to trace one by one, it will be difficult. In our class, or in these classes, we have been working with each effect separately. When they are combined together, it will be best for you to just use what? A calculator. From what we had before, the graph of a sine, the graph of a cos. Whatever that you be given, y is equal to 2 sine of x minus 45 degrees, then minus 1. To analyze everything from the original graph, then to this one, it will be difficult. So we are going to talk about that as a separate class for you to just sketch that graph with your calculator. You can have the points, and those points you just use them on your graph. Then you can draw or have a sketch from there. So this is it. This is the basics. The basics as we are using the transformation in our trigonometric graphs. So let's do revise as many questions as we can.